In this video, you will learn how to convert existing KSS 8.7 robot programs to iiQKA.OS2 version 9.2 using iiQWorks.Sim. We start in iiQWorks.Sim, where the simulation environment is already prepared. The layout from the original KSS 8.7 robot cell has been imported, and all major components such as the robot, tools, and cell objects are already available in the scene. The first step is to verify the robot. The robot has already been added, and there are no custom programs yet. Everything is still at the default state. This cell uses a KR140R3200PA palletizing robot. If you navigate to the Program tab and look at the Program Overview, you can see that only a default main program exists, and it cannot be deleted. Since the default main program cannot be removed, it is renamed. If you want to rename an existing program, you have two options. You can double-click directly on the program name, or you can right-click on the program and select Rename from the context menu. This allows a new main program to be imported without conflicts. Next, the palletizer folder and the master program that were previously sent will be imported into the controller. Before importing, the installed options are checked to confirm that the required user interface packages are available. The Creator option and User Technology options are added. This ensures the correct interfaces are available for the palletizing application. A bag gripper is already present in the cell. Bags arrive on the infeed conveyor and are picked between the conveyor and the pallet positions. The KRL code provided is from a working KSS 8.7 system and comes from a standard template program. To import the programs, go to the robot controller, select Import, and choose to import an entire directory. The palletizer folder is imported first. Next, the master source file is imported separately as a KRL file. This program will act as the active main program. After activating the master program, errors are expected. A common issue occurs in DAT files due to deprecated motion parameters. One frequent problem is the presence of velocity values in DAT files. These parameters are no longer required and will appear as errors. A regular expression is used to quickly locate and remove all velocity entries from the DAT file. Let's select a program with a DAT file. In our example, it is the main program. Click on the KRL and DAT view buttons on the top right corner of the programming window so that both are highlighted in blue. In the dot view, you will then see the red-marked velocity values that can no longer be interpreted by iiQKA.OS2 version 9.2. If you would delete it manually, the error would disappear. But there is a more convenient way on how to convert your KSS 8.7 program to iiQKA.OS2. Please use the shortcut Ctrl F to open the search functionality. On the top right corner of the search functionality, you can use the drop-down menu to view the search and replace function. Next, you need to select the button with the little asterisk or star symbol to select the use of regular expressions. Using the search and replace dialog with regular expressions enabled allows all matching velocity values to be removed at once. The regular expression searches for the word velocity followed by any numeric value and a comma. This ensures all invalid entries are removed. After replacing the matches with nothing, the DAT file errors disappear. Type in the regular expression \bVEL space \D asterisk dot question mark \D asterisk comma and click on the button. Replace all expressions. Now you want to go through all other programs that also use the vel parameters in the dot file. Copy-paste the regular expression in the search functionality and replace them with nothing. The velocity parameter is deprecated in newer motion commands, which is why it must be removed when importing older projects. The next step is handling tools and bases. The current config.dat file contains only default values. Instead of manually typing all tool and base data, the config.dat file from the old system is reused. Tool data is copied from the old config.dat file and pasted into the new config.dat file. Base data is copied in the same way. Load data is intentionally skipped to avoid incompatibility issues. the load config.dat into simulation button is pressed. This applies all tools and bases to the virtual controller. Once loaded, pallet frames and infeed frames appear in the correct physical locations instead of being centered at the robot base. Checking the device's view confirms that all tool and base data has been imported correctly. This method avoids manually recreating tools and bases and is especially valuable for system integrators. We can now click on play and see the machine data of iiQKA.OS2 being created with the RCS module inside iiQWorks.Sim. And the robot moves into a first position, confirming our successful conversion from the KSS 8.7 program to iiQKA.OS2 version 9.2. The master program is running and calling the main palletizing logic. The program stops because it is waiting for an input signal. The signal is monitored to identify why execution is paused. The input condition is temporarily bypassed by replacing it with a Boolean variable for simulation purposes. After resetting and restarting, the robot begins moving, confirming that the program logic is functioning. Additional position adjustments and variable initializations are made to improve motion behavior. The robot continues running the imported KRL palletizing program successfully in simulation. The simulation speed is increased to accelerate testing and validation. Trace visualization clearly shows the robot motion path during execution. Debugging tools and robot controller simulation allow monitoring of global variables in real time. The palletizing sequence completes one side and transitions to the opposite pallet as expected. The conveyor is locked to prevent unintended movement during testing. The monitoring window is reopened to continue observing variable values. A test mode variable is enabled to step through individual motions one at a time. This allows precise debugging of each pick-and-place operation. Disabling test mode allows the robot to resume continuous operation. Additional global variables such as bag number and layer number are monitored. This confirms that the palletizing logic is progressing through layers correctly. The most important takeaway is how to migrate config.dat data, including tools and bases, from older systems. Converting systems from KSS 8.6 or 8.7 to iiQKA.OS2 is very achievable with these steps.
Thank you for watching. We hope you find this video tutorial helpful. Don't forget to follow the KUKA channel for more updates and more exciting content. If you're looking for hands-on training, visit the KUKA College to enhance your skills. See you in the next video.
Making automation easier.